All right, let's take a look at our lesson for today. So we're going to be working with area of a triangle. For this, we've got two different formulas that we're going to go over. These really we could call the Precal formulas for area of a triangle. We know the regular old area of a triangle formula. We've been using it for a long time, right? It's just area equals 1/2 base times height. So that's our regular old area formula. These new area formulas take into account different pieces of information that we would have. In the first case, for using this one, this particular formula right here, what we would need would be, actually we need side, angle, side to be able to do this one. If we don't have side, angle, side, we would have to find the parts of the triangle to give us side, angle, side. The angle has to be, the included angle. It has to be side, angle, side. It has to be included between the sides. So that's the criteria for using our first one. And it's simply 1/2 side 1 times side 2 sine of A, angle. This is my angle A. The second one, this is called Heron's formula. This is for if you have side, side, side. You don't have any angles whatsoever. And you could find the angles. We know we can use law of cosines to find angles, but if you want to, not go through that process, don't use law of cosines to find some angles, then you could do this. You could use this formula, Heron's formula. It doesn't really matter which of the formulas you use. You're going to get the same answer, the same area answer. It's just depending on the information that you have to work with. Now, Heron's formula uses something that's probably, you may not have heard about this or used it before, but it's called a semi-perimeter. So that's what this S stands for, is the semi-perimeter. And it's kind of how it sounds, like the English word. You take the perimeter and you cut it in half. So I would add all three sides of my, triangle. And then I would multiply by half, and that would give me my semi-perimeter. And you can see that the semi-perimeter is used 1, 2, 3, 4 times in the formula. So it's a very important number for this particular formula. This is the semi-perimeter. Okay, and those are the two new equations that we're going to practice with today for area. Questions so far on the formulas? Okay. So let's look at our first example. So here we've got, let's draw our triangle like we normally do. So let's see, H, P, J. Let's see, side H is 5, side P is 7, side J is 11. So this we have side, side, side. So the quickest way to find our area would be to use Heron's formula, because that one just needs sides. So in order to use Heron's formula, we need to find our semi-perimeter. So the semi-perimeter is going to be 1/2 times, and we're going to add up 11 plus 7 plus 5. Okay, and of course we're going to have a calculator. We would be able to use our calculator to do all this. We get 23/2. If you wanted to put that in decimal form, you totally could. I kind of prefer fractions, but you could write it as a decimal, be fine. So now let's fill out the formula. So the area is going to be, so it's the semi-perimeter times the semi-perimeter minus the first side, 11, times the semi-perimeter minus the second side, or side 7, times the semi-perimeter minus the last side. Now we're going to go to our calculator and input all that. I just want to do that with you just to make sure we're comfortable. But that is the setup of the formula. Are there any questions about setting up the formula? We okay? Okay, so let me pull up my calculator. So we're going to do the calculator part. And I'm going to do control x squared so I can get a radical under there. I want the fraction, so control divide gives me a fraction. So 23/2. Okay, times, open parentheses. Then I'm going to do control divide. So I want a fraction again, 23 halves. And then we are minus 11. Close those parentheses. Times, open another parentheses. 23 halves. Subtracting the next side measure, which was 7. Close those parentheses, times, and this is our last third set of parentheses. Okay, my fraction bar, so I've got 23 halves. And now minus the last side, and they don't have to be in any specific order, ladies. Any order is fine. And now I'm going to do Control Enter, and that's going to give me my area. So 12.9687. So let's navigate back to our document. And so my area is 12.9687. The textbook is the problems are typically going to want you to round to the hundredths. So if we were putting this problem in as an answer, we would put 12.97, and if there were units, they would be squared, right? Because this is area. There aren't any units, but if there were, it would be units squared. And that's our very first use of Heron's formula. How are we with that? Everybody okay? Okay. So let's navigate to our second problem. On this one, we've got a different triangle. Okay, so let's move over here. So we have a different triangle. So triangle ABC. Let's see, measure of angle B is 64 degrees. Measure of angle C is 38 degrees. And side B is 9. All right, so I don't have all the sides, so Heron's really wouldn't be a great idea for me. The other formula needs side, angle, side. That would kind of be the best option for me. We're going to have to use, let's see, we're going to have to use law of sines to get our other side. But I would like to go ahead and find the angle measure. Is that all right with y'all? So I know I can set up like sine of 64 over 9 equals, it doesn't really matter. I think I set it up. So I'm going to add these three together. And so I got 180 minus 64 minus 38. That's going to give me 78. So 78 is my missing side measure. That's a 9. And so I'm going to do sine of 78 degrees over A. So I'm going to find side A so I can get side, angle, side. Is that the one I had to do? No. I could have done, if I wanted to, I could have done, say, side, angle, side. I could have done that instead. So it really is totally up to you which one you want to do. I just chose that one. So let's do that. So we would cross multiply. We get 9 sine of 78 degrees equals A times sine of 64 degrees. Solving for A, we get 9 sine of 78 degrees over sine of 64 degrees. Now I'm going to go ahead and put that in my calculator. So let's go back to our calculator. So I'm going to do a fraction, control divide. So 9 times, now I'm in degree mode, and that's what I need to be in when I'm putting in degrees for trig functions. So just be sure you're in degree mode. All right, sine of, what was that, 78 degrees over sine of 64 degrees. Okay, so this gives me my side measure, 9.794. Okay, so let's go back here. So A is 9.794 and then a bunch of decimals. Please never ever round until the very end. And I'll show you. We're just going to keep that whole number. We're going to keep the whole number. So if I set up my area formula, I've got 1/2. So we're using, and this is the 9.7 deal. So 1/2 times 9 times 9.794, all of that, sine of 38 degrees. Okay, so that's, I'm going to go back and I'm going to put all of that in my calculator. So using my formula, 1/2 times 9 times the measure we just found times sine of 38 degrees. All right, so let's do that. So here we go. So I'm doing a fraction because I like to. You don't have to. You could do 0.5 if you wanted to. That's fine. 1/2 times 9 times. Now I'm going to use my arrows and I'm going to scroll up and highlight this number. And when I hit enter, it puts it down here in all of its beautiful glory, all those numbers. That's what you should do. You should never get rid of a number. Don't round until the very end. Times, and then we want sine of 38 degrees. And that gives me my answer of 27.1357. So that's my area. So let's go back. Okay. We've got the area is going to be 27.1357. If we were putting it in our textbook, they would want us to do 27.14, and there's no units, but it would be units squared. All right, so we've had an example of using each of the formulas, Heron's and the other formula. How are we doing? Everybody okay? Okay. So the last one is really, part of it is a blast from the past, but let's look at what we're doing. So they want us to find the area of the segment, the blue part basically. The radius of the circle is 8 feet and the central angle is 70 degrees. So let's think about that for a second. That portion outlined in pink, do you see that right there? Do you remember what that's called, that portion? The whole portion is what? Starts with S? It's okay. Sector, remember? You're like, oh, sure, Dr. Wright. Yeah, of course. Right? You're like, no. Okay. So we learned, it seems like so long ago, but we learned at the beginning of the year how to find the area of a sector. Okay, we did. So think about finding the area of the sector. We're talking about now, today, finding the area of the triangle. How can those two concepts give me my blue shaded area? What would I do? Yes, ma'am?
Area of the sector minus area of the triangle.
Perfect. That's exactly right. I would find the area of the sector and then I would subtract out the area of the triangle. Okay, that's our goal. That's what we want to do. We want to find the area of the sector and subtract out the area of the triangle. Okay, great. So we know what to do. So I'm going to write the area of the sector formula over here. You may have forgotten it. I don't know. Maybe you remember it. It is 1/2 r squared theta, where theta must be in radians. That's a requirement for that formula. Theta must be in radians to use the area of the sector formula. Okay, well, we can do that. All right, so let's just work on area of the sector because that's what we started with. Why not? So area of the sector is going to be 1/2. My radius is 8. My angle measure is 70, but it's in degrees. Do you remember what is the conversion for changing from degrees, excuse me, degrees to radians? What do I need to multiply that angle by? Pi over 180. Great job, ladies. That's exactly right. Pi over 180. And I'm going to put all that in my calculator all at once, that whole thing. 1/2 times 8 squared times 70 times pi over 180. Since there's no trig involved whatsoever, it does not matter whether I'm in degrees or radians. It does not matter. Okay? We're just multiplying a bunch of numbers together. That's all we're doing. So let's go back to our calculator and let's multiply that bunch of numbers together. So we've got, what do we have? We have 1/2. Whoops. Okay, go down, put the 2, there we go, 1/2, and then we've got times 8 squared times 70 times pi over 180. So pi, it's down here, over 180. Okay, so we're going to put all that in at once, hit Control Enter. That's going to give us our approximation. And I'm just going to leave it there. It's the 39.095, you know, blah, blah, blah. Okay, that's the area of the sector. So let's go back and just write that on our paper. So the area of the sector is 39.0954, etc. Okay, great. So we have the pink part. We found that area. Now let's focus on finding, you know, our new formula. Find the area of the triangle. Let's see. I know this is 8 feet because it's the radius. We've got side angle side, don't we? We have side angle side. So let's use our side angle side formula. So A equals 1/2 times the first side, which is 8, times the second side, which is 8, times sine of 70 degrees. Now, since that's a trig of 70 degrees, I have to be in degree mode. There's no option for me. I don't have a choice. So this is the area of the triangle. I'm just going to put like a little triangle symbol there. This is the area of the triangle. All right, so let's go back to our calculator. So it's 1/2 times 8 times 8 times sine of 70 degrees, and I am still in degrees, so it's not a problem. Okay, Control Enter. There's my triangle area. My triangle area is 30.070, etc. Okay, so let's go back and just write that on our page. So the area of the triangle is 30.0702, etc. So our actual area of, we'll just call it area of the blue. Area of the blue sector is going to be 39.0954 minus 30.0702. And of course, we're going to go back to our calculator because our calculator has all those numbers in it. Gosh, I can't even draw straight. There we go. So let's go back to our calculator and let's subtract those. So what I'm going to do, I'm going to use my arrow. I'm going to go up, highlight that first number and hit Enter. That pulls it down in all its beauty. Minus, let's use our arrow, highlight that one, hit Enter. There we go. We're going to subtract those, and that gives us 9.025. Okay, that's the actual area of that blue portion. All right, so let's go back over here, wherever I was, right here. So the area of the blue is 9.025, and we do have units, it's feet, so that would be in square feet. All right, how are we doing?